Welcome to Group 5 presentation. We are going to present about port scanning and vulnerability scanning techniques. Hacking is the process of finding vulnerabilities in a system and using those vulnerabilities to gain access to perform malicious activities. These activities span from deleting files from the system or stealing sensitive information. The hackers are categorized into three main groups. We've got the white hat, the black hat, and the grey hat. More or less of the good, the bad, and the ugly. For the purposes of this presentation, we are going to focus more on the effort of the hackers in identifying vulnerabilities, the tools that they use on port scanning and vulnerability assessment. There are 5 major types of hacking, which are the computer hacking, password hacking, email hacking, network hacking, and website hacking. Scanning is the second distinct phase of hacking. It follows under reconnaissance, after information has been gathered about a target. Port scanning is to find open ports to counter network hacking. Ports can be described as gates into your hardware. There are 65,536 different ports, with each assigned to a different network port. URLs are converted to an IP address reference number. The receiving web server destination port changes, that is, changes from HTTP, SMTP, FTP, HTTPS to a port number. 0 to 1023 are well-known port numbers. 1024 to 49151 are registered port numbers. 49152 going upwards are dynamically assigned port numbers. Port scanning is the process of sending packets to specific ports that are open and could be receiving or sending data on the host. This involves analyzing the response to the identified vulnerabilities. There are 3 types of responses, which we mentioned earlier on. We have got the open, which means the service is listening. We have the closed, which means not listening. And we have got the filtered, which means there is no reply. We have got a transmission control protocol, the TCP handshake, which uses a 3-way handshake to establish a reliable connection, and it is flagged by synchronization, which is SYN, sync, and ACK, which is acknowledgement, and sync ACK. Both sides must be in synchronization and acknowledge each other. And of course, if the port is closed, a reset RST packet is sent. Examples of 5 basic port scanning techniques are the pin scan, the TCP half open, the TCP connect, UDP, stealth scanning. And the stealth scanning is explained in detail. Stealth scanning works by crafting packet flags in such a way that you can try to induce some type of response from the target without actually going through the 3-way handshaking process and establish a connection. The scans are unlikely to appear in logs, and they are some of the most minimal port scanning techniques available. With stealth scanning, if you do not receive an open port, you know that the target is not running a Microsoft OS. Under stilt scanning, we have got different types of scans. We've got the fin scan, the Xma scan, the null scan, and the idle scan. The fin scan. On the fin scan, a packet is sent to a target without first establishing a connection. A reset packet is received back from the target due to the way the request for comment, which is the RFC, is written. The portal is considered closed. If no packet is received at all, the port is considered open. We have got the Xmas scan. The Xmas scan is more or less the Christmas tree scan. It raises packet flags like Christmas tree lights. It sets a TCP packet with the URG, push, fin, and flags and fires to the target. Again, if there is no reset response, the packet is considered to be closed. Sometimes fin packets go unnoticed by firewalls because they are mostly looking for a sync packet. This is actually a sneakier way to learn a target network potential. On the other hand, null scan do not set any flags on the TCP packet, and no response is considered as open. We have got the idle scan. The idle scan is known as the dump scan, a TCP port scan method that consists of sending spoofed packets to the computer to find what services are available. This is achieved by impersonating a zombie, another computer whose network traffic is very slow or non-existent, as in not transmitting or receiving information. There is no interaction between the attacker computer and the target, as the zombie computer acts as an intermediate. Hence, the attacker benefits an IP-based relationship between the machines, the target machines, and him or her. Hence, he remains completely invisible to the target host. In summary, null scan do not set any bits. FIN scan sets a TCP FIN bit. Xma scan sets the fin, push, and the URG flags, and lastly the idle scan sends spoofed package. Nmap is a port scanner that is used to scan ports. It takes IP address of the host and name and then finds the basic information related to it. It also finds the number of ports that are running on that particular host, the number of ports that are open, closed, or filtered. It also identifies the operating system used by the target, including the versions used. It also predicts the type of attack the system is most vulnerable to by the use of graphical format. None of that have been highlighted. Now that we have highlighted the open, the closed, the filtered ports, how then do we defend the ports against scanning? We can install firewall, we can install TCP wrappers, we can install TCP wrappers, we can undercover holes in the network. Let me move to our second presentation, vulnerability assessment. A vulnerability assessment is a systematic review of security weaknesses in the information system. It evaluates if the system is susceptible to any known vulnerabilities. It assigns alert levels to those vulnerabilities and recommends mitigations if and whenever needed. There are several types of vulnerability assessments for the purposes of this presentation. We have highlighted host assessment, network wireless assessment, database assessment, and application scans inter alia. The security scanning process consists of four steps. We've got testing, analysis, risk assessment, and remediation. On testing, the objective is to document a list of applications vulnerabilities. Security analysts test the security health of applications, servers or other systems using manual or automated tools. We can use tools like the Nexus. Analysts refer to vulnerability database such as the CVE data, which is from the NIST, vendor vulnerability announcements, asset management systems, and threat intelligence feeds. On vulnerability assessment, which is the step 2, the objective is to identify the source and the root cause of vulnerability, and identified in step 1. That is identified in step 1. It involves the identification of a system component responsible for each vulnerability. For example, an old version of an open source library means providing a clear path to mitigation. After analyzing vulnerability, an analyst does a risk assessment. The objective here is to prioritize on the levels of vulnerability. This is done through assigning a rank of severity score to each vulnerability based on the system affected, the data at risk, the business function at risk, the potential damage inter alia. The rankings are based on the CVSS, Common Vulnerability Scoring System. The final step of the process is the mitigation. The objective of this step is to close security gaps. It is a joint effort by security staff, development and operations team, determining the most effective path for mitigation of each vulnerability. Mitigation steps include introduction of new security procedures, measures and tools, updating and configuring changes, developing and implementing vulnerable patches. The process must be repeated in a process known as the DevSecOps. Vulnerability assessment uses different techniques, namely the static analysis and the attack graph analysis. Static analysis is a fast and reliable technique which focuses on the analysis of program structure using various means. It emphasizes on the analysis of the code of the program in order to detect the flaws present in it. Types of static analysis includes the lexical analysis, which includes, of course, codes like ITS4, the check style, and the PMD, type, interference, constraint analysis, among others. On attack graph analysis, it involves a brief representation of all the paths followed by an attack. The desired state may involve changing the network, stealing the network packets, or gaining a complete access over it. The attack graph also helps in determining the security weaknesses that lie in a network, and this has however become the most used approach in network security. Most of the vulnerability assessments have recorded pure human capital, non-technical issues. Hence the need to also assess employees and verify what training needs can be effective, which employee represents the highest risk. We have examples which are driven by human capital. Tailgating, for instance. We've got employees that follow co-workers to access passwords, and trick other staff. Other than mentioned techniques, assessment can be done through baseline reporting, code review, attack surface review, architecture review, design review. The slide indicates some of the common port scanning and vulnerabilities tools that are used in ethical hacking. These are such vulnerable management programs. It is also important to have a comprehensive vulnerability management program in order to adequate secure organization. And these highlighted key components: the asset and vulnerability discovery, vulnerability and risk prioritizing, and then the patch management. These are used to address vulnerability in an organization. Allow me to say, on behalf of Group 5, I thank you for your attention.